Good evening. Now, purpose of this video, so you can able to feel comfortable before your last test, and the kinematic is one of the chief chapter we can say that it will come. So let me quickly tell you what will be your flow. So you can understand that this is a concept flow chart, so which you can able to address. How many chapter it will come in, what should be the sequence of it. So here we can say distance and displacement. Basically, the distance is actual path covered by the body. Let's say the body has covering actual path, so this is actual path, that is distance. And the shortest path between, shortest path, let's say this is the shortest path. So all are reflected with respect to vector. So these are the two vector that is called as position vector. And this is called as displacement vector. So always remember, by this way we can represent distance and displacement. Now, once we are talking the horizontal motion, so in horizontal motion, there are so many question it will going to be draft. Like, what is the speed, then average speed, velocity, average velocity, then next acceleration, average acceleration. Then there's a one more word that is called instantaneous acceleration or velocity. So these question it will come in horizontal motion, and we will see one by one the detailing of it, but not in this video. Acceleration. Basically, acceleration is defined at delta V upon delta T. So, or we can say V final minus V initial, but this is a vector form divided by delta T, and this is called acceleration. Now, once we are talking about acceleration, to one of the common and important part is acceleration. This acceleration have a two feature. A is equal to constant and A is variable. Once we are keeping A is equal to constant, so we will apply V is equal to U plus AT. Let's say plus and minus, acceleration and retardation both we are correct. S is equal to UT plus minus half AT square, and V square is equal to U square plus 2AS. So they are plus and minus. So this is the set of equation that we will use when we are considering acceleration as constant. And once the acceleration is variable, so we will use v is equal to dx over dt, and a is equal to dv over dt, or v dv over dx. So kindly remember the two cases we will going to address the problem in the given acceleration section. Now, once you are talking the vertical, so you will say in vertical all equation remain same. X will replace by h, and a will replace by minus g. Always remember, a will replace by minus g. So once again, if you are keeping all the value, so we will get all the motion in vertical plane. Fine. All set of equation, like if we can say acceleration, retardation, six equation will there. In the same way here as well, six equation it is available in vertical section. Now once we are talking about the graph, so we have a three type of graph. We can say xt graph, vt graph, at graph. X to v, you already knowing differentiation. A to v to a, once again differentiation. And the reverse journey, it will going to be take acceleration to velocity integration, fine, let's say dt, and v to x once again integration. So kindly know this sequence that will very helpful for understanding of the graph. Now few more things about there. Xt graph only remember slope. Slope will going to give me speed or velocity. Fine. Vt graph is very important. Here slope, it will going to slope will give me acceleration, and area will give me displacement. Correct. Area will give me displacement. Now once we are talking about AT graph, the AT graph is not that important but better to know. AT graph slope will give me jerk. Slope will give me jerk. So it's better to remember the AT graph. There are few more graphs. Maybe you can see like VX graph will also there. AX graph it will also there, and we will surely see the numerical that is based on it. So how many graph are there? One, two, three, four, and five. And there are few detailing of it. Now the last part of this section it will come, that is called as relative velocity. And relative velocity, always remember velocity of A with respect to B. I already told you this is a vector equation, velocity of A minus velocity of B. This equation will give you a lot of solutions, lot of cases. Must only remember this velocity formula, that's it. Apart from it, let me quickly tell you and show it to you a few formula chart that will going to address the thing very quickly and very productively. Fine. So let me show it to you. Here it is. There's a mind map formula that will going to help you out in so many regards. And this is with a straight line, this particular section will going to, this is whole in one page, we can say. Let's quickly see motion, reference frame, distance. There's a motion, reference frame, distance, displacement, speed, velocity, or we can say average speed, instantaneous speed, average velocity, instantaneous velocity, and here you can say average acceleration, instantaneous acceleration, uniform acceleration, non-uniform acceleration, and kinematically we can say these are the, for uniform accelerated motion these are the equation. And one more equation I thought we have missed, that was equation in nth second. This equation is also important, nth second. And once we have a variable motion, you better to use the integration. These equations are important. In variable we will use integration to solve those equations. Now motion under gravity, here you can say these are the very important three equations for calculation, and vertically up and vertically downward motion. Now the last but not least, the graphical presentation I told you, ST, VT, AT graph, and the last one is relative velocity. Relative velocity I told you only one formula we will use, and since in one direction we will not use vector, but if we will use the vector equation means the, we can say we can going to be used, because relative velocity will be 1D, it will be applicable, and 2D both. So we will see its implications when we'll take the problem, but right now this is very much clear ki how to approach this particular chapter. I have given the brief introduction so you can able to use all the formula chart, and effectively you can learn the things. So next video we will just going to see section by section the discussion, DPP discussion. Till then, take care, have a nice time, and bye bye.